sorry I forgot to tape to do it. Such is life. They should be pretty straightforward things. Where is it? Not come on yet. Oh, it was on there. I couldn't see it. Okay. Now, what we're saying here is that Mia said that if she graphed it, she found that it touched the x-axis at negative 10 and 4. And those are called the roots or the zeros of the equation. But part A is saying, given this quadratic equation, can you find the points where it crosses the x-axis? And one way would be what we call graphically. We just did that. But I think they're getting at deeper. That's what the Common Core likes to do. And what they're getting at is, what is the y value when you cross the x-axis? What is it? 0. So instead of putting y here, I'm going to put 0. And now I'm going to solve this quadratic equation, which comes up with x plus 10 times x minus 4 equals 0. Maybe it's the guy on the left. I'm going to kind of reverse it over here a little bit. And then maybe it's the guy on the right. And you know how to do this, right? Minus 10, and I get x equals negative 10, and then plus 4 and plus 4, and I get x equals 4. You guys should be pretty clear on that, right? We just did 2 questions like that and so on and so forth. Again, that should be routine and very straightforward for every person in the room. Yeah, what I do want you to notice is this. Whether I do it Mia's way, where I actually graph it and I look at the answers, or if I do it algebraically, I get the correct or same answer. Does everybody agree with that? Okay. And that's one of the reasons why we have 2 names for this. The roots being where it crosses the x-axis, or the zeros being where I substitute the 0 in for y. But it's the same exact concept, it's the same exact idea. Well, now today we're going to get into something which is a very similar idea, and what today is really about in a lot of ways is working backwards. It says here, how can we write a corresponding quadratic equation if we're given the pair of roots? So now, let's pretend we reverse the question, okay? Let's say that we knew the roots were negative 10 and 4. What is the quadratic equation? Well, watch this. One of the roots is negative 10. One of the roots is 4, agree? Now, checking out what we did here, I can reverse all the steps. If x was negative 10, then didn't I have to subtract the 10 from both sides to get to that point? Right? So if x is negative 10, then isn't it true that the factor has to be x plus 10? Does that make sense to everybody? Right? Look at it this way. If it was x plus 10, wouldn't you subtract the 10 to get to negative 10? And then here, since this says x equals 4, what's the factor? X minus 4. Good. But then that means that if I go backwards another step, didn't I have to have the line that says x plus 10 times x minus 4 equals 0? In other words, the step before we say, maybe it's the guy on the left, and maybe it's the guy on the right. Agree? Now, this is what you get after factoring. Factoring is anti-distribute. So if I'm going backwards, now I got to double distribute and see what I get. I get x squared minus 4x plus 10x minus 40, which is x squared plus 6x minus 40. And then since it's an equation, it's going to equal 0. Well, look at that. So the point being, not only can you start with the equation, and figure out the roots, what is it also possible to do? Start out with the roots, and then what? Figure out the equation by working backwards. Okay? All right, so part C says, in the last lesson, we learned about the symmetrical nature of the graph of a quadratic equation. That was when we filled the table in. That was all on the quiz. Remember that? Filling in the table. How can we use that information to find the vertex? This is actually pretty cool. If the roots are negative 10 and 4, doesn't the axis of symmetry have to go right smack in the middle? Does that make sense? Yeah. I'm getting this blank stare from the back of the room there. Does that make sense? Is it that easy, or am I like over your head? Yeah. We're good, Michelle? Okay. Now, what number is right smack in the middle between negative 10 and 4? Negative 3. Good. All you got to do is add them and divide by 2. Negative 10 plus 4 is negative 6. Divided by 2 is negative 3. The middle is the average. To average, add them up. Negative 10 plus 4. That gives me negative 6 divided by 2. Now, since this is the axis of symmetry, I would not put negative 3 as the answer. If I wanted the axis of symmetry, what would I put? Everybody?
X
X equals -3. Why it's all over that one. Now, it wants the coordinates of the vertex. Well, isn't it true that the x coordinate on the vertex has to be -3?
Yeah.
How can I figure out why? Andre? Go ahead.
Put in the -3 in the x.
Yeah, absolutely. Go back to the original equation, put in the -3 for the x, and see what we get. So in the original equation, x squared plus 6x minus 4, what's -3 squared? 9. What's 6 times -3? -18 minus 40. So this is -58 plus 9, which is going to be, I believe, -49. And there's my vertex. -3, -49. Okay? Now, I would also like to take 1 second to just remind you that not only can you find the axis of symmetry by splitting the roots, or any other pair of numbers that you know are corresponding because of the symmetry. You can find the axis of symmetry by graphing it, but occasionally they ask you to find the axis of symmetry using a formula. And I showed you the formula for this the other day, and I just want to very quickly remind you of this formula. We don't use this very often, so I would suggest that you make it a point to memorize this one. Axis of symmetry is x equals -b over 2a, where we're dealing with the same ax squared plus bx plus c. So it's -b over 2a. If we were to plug it into this one, b is 6, so I'm going to get -6 over 2 times 1, which is -3, and that's what we got. Remember, x equals -3. Okay. Turn a page. I don't think that's a very hard formula. I think if you remember the formula, it's pretty easy to do. Okay, so now, let's take a similar, oh, you know what I want to do even before I go to A and B? I want to take 2 minutes and I want to do one more of these things that we've done the last 2 days in a row. Remember these? Where we start with y equals ax squared plus bx plus c. You find the y-intercept and then you use the other 2 points to generate the 2 equations. I'm going to give you about 2.5, 3 minutes to get that done. Please feel free to talk to people around you about what answers you get. Okay? Noise is a good thing now. As long as it's about the right stuff. Feel free to refer to your sheets from the other day. That's a good thing. I have to get my, I don't know, cracker power. This is ever missing. I don't know where to look. Take a look, see what you think. Yes?
Does it matter what points you put first?
No? Yes? What was that?
I did. Could you have multiplied 1 by 6?
Oh, you
and
got
4
rid
by
of
3?
like a different variable or whatever?
I got rid of the same b, but I did.
Like a
6 and
greater
3.
common multiple?
Yeah, I
Yeah,
thought,
that's fine.
Because I thought that you couldn't just do 1 by 2 and not the other.
Oh, yeah, you could, but your works fine too, and you probably got the same answer, right?
I didn't get to finish.
Okay, if you had, you would, assuming no mistakes, you know, arithmetic, then you would come up with the same exact answer, as provided, of course, you matched up a variable.
Yeah, I multiplied the first one by 6 and the second one by 3.
Yeah, which, and if you notice, 6 and 3, the only difference is the factor of 2. Okay? Any other questions? Again, this is probably the third or fourth time I've said this. I believe this is the most challenging question of the year. Maybe it's not the hardest thing to understand, but it requires the most work. And it's certainly not easy to understand. So if you can learn this, you're in really good shape. Yes?
All right. Now, just one question. Where does the 2 come from when you multiply it by 7?
Here?
Yeah.
I want to match the b's up. I can't just, see, if I add like it is here, I don't get rid of the b's. But one thing about an equation is I can multiply everything in the equation by the same thing and I don't change the answer. So when I multiply it by 2, I get 14, 2 times 7, 2a, 2 times a, and 2b, and now I can add negative 2b and positive 2b, and I get nothing out of that. All right, if I left it without the 2, then that would leave a b there, and then I would have 6 equals 6a plus b. Well, what does that doesn't mean anything. I can't solve that, okay? All right, so again, that's very important. Now, going back to the days of Mr. Braids in high school, oh! You gotta lock yourself in a closet. Think about this stuff. And it's the truth. You know, this is not easy. And sometimes you just got to dedicate some time when you're home. And obviously, to lock yourself in a closet is not literal. What it means is you need to focus. You need to step everything else out of your life for a few minutes. You need to focus on this and make this what matters. Okay. So now, let's go backwards a little bit. And let's work on those 2 previous questions, particularly the first of them. The second one, this one here, you can just put in a graphic calculator, right? But let's do the first one, noticing this whole idea of symmetry. Now it says the roots, now notice this. First off, it's negative, that's worth noticing. That means it goes like this, right? The roots are going to be negative 2 and positive 5. Does everybody agree with that?
Yeah.
Okay. So, what's the axis of symmetry going to be? Yes, what number's in the middle? Minor?
2.
1, 2, 1, 2. I don't think so. I'm going from negative 2 to 5. That's a distance of 7. If I cut that in half, it's 3.5, right? 1, 2, 3 and a half. So my axis of symmetry is going to be right there.
Isn't that
What's that?
2.5?
1, 2, 3 and a half. 1, 2, 3 and a half. Okay? Now the equation of this axis of symmetry is x equals 1.5. All right? But I'm not looking for that equation right at this point. I'm looking for the turning point. If I plug a 1.5 in here, all right, all you got to do is plug the 1.5 in for x, multiply them, negate them, and the graph is just going to go upside down like that. Hasta la vista, vaya con Dios, toodaloo. Arrivederci, smile a lot, ciao. Arrivederci, adios amigos, see amigas. Cheerio, toodaloo, ta-ta. Molly, you look very comfortable here.
To the health office.
You look like you're in pure comfort mode.
That's because I'm going to be on the clock, so I have to be comfortable.
Oh, yes, I agree. I wish I was in comfort mode. I'm in relaxed
We're gonna
mode, not
correct
quite to the
guidance.
comfort
We're gonna
level.
correct the guidance.